Hi everyone. The goal of this presentation is to show you how to do production bundles in Angular. I'm going to go through a few different methods and talk a little bit about the pros and cons of each one. So when you're doing production builds in Angular, the two most important parts are ahead of time compilation, or AoT, and your bundling. And I'll talk about each one, but let's start by talking a little bit about what compilation really means in Angular. When you're talking about compilation, you're typically talking about template compilation, because when you write your Angular components, you use a lot of Angular specific syntax, right? Like ng-for, ng-if, and other like built-in Angular expressions. And that's not in a format that the browser can understand. So that's why Angular provides a template compiler that can compile that down into executable JavaScript. And so let's just take a look at a quick example here. This is something that you might write in your component, right? You have an ng-if binding here and a simple property binding. And this is pretty straightforward for you, right? But the browser can't make any sense out of this, right? So what the compiler actually does, it takes this and converts it into kind of like a JavaScript representation of it, and that looks like that. And obviously this is kind of ugly, and you never have to really, you should never go in and hand edit this, of course. This is generated code that the compiler handles for you, but if you kind of look at it, you'll see some of the, if you go back, you remember we have a div here and we have an ng-if. So if you kind of glance at this, you'll see here, I guess the mouse isn't, you'll see, if you look at it, you'll see like the div string here, because it creates a div, and you'll see the ng-if down here. And but so really what's happening here is when your application runs in the browser, this is what runs in combination with, it discards the template that you wrote, but it actually combines this with the controller class or component class that you wrote, because it still needs that part for the business logic, because you may have some business logic in your component. So it combines the two of them, and that's essentially what runs. But you don't have to understand this syntax at all to do anything with Angular. This is really just, this is for the browser, not for us, right? And the compilation comes in two different formats. There's ahead of time and just in time. And the difference is really not so much what happens, it is more about when it happens. And I'll talk about each one. So yeah, the just in time compilation is really compilation on the fly in the browser. So what happens, you request your Angular application in the browser, it loads up, and then it does the compilation, that translation from the Angular specific syntax to that JavaScript representation that we just looked at. And obviously there's a downside to that, because that means that there's a delay in your application rendering, because before you can actually start rendering your app, you have to actually do this compilation step. And this is likely to become a performance problem in large applications, because the bigger the application, the more compilation needs to happen. And the other problem with this is that you have to actually ship the compiler down to the client, because you need it at runtime. And the compiler is one of the bigger parts of the actual Angular framework. So it grows your footprint, like the application's footprint, because you now have to download this compiler. And so switch to AoT, or ahead of time compilation. It basically does the compilation ahead of time, really, as a build step. So before you actually deploy your app, you do this step. And the nice thing here is there's no more runtime penalty, because you don't compile at runtime anymore. You do it at build time. So your browser can render the application right away. And another big benefit, you no longer ship the compiler, and that is a relatively big impact in terms of the bundle size. If you don't ship the compiler, your footprint, or Angular's footprint, is smaller. So that's nice. So in production, you should always do AoT because of the benefits. But it can be a little impractical during development because the compilation time is relatively long, especially in a large application. So what I recommend doing is doing just-in-time compilation during development and then do AoT for your production or your higher environments. But I know the Angular team is working on speeding up the compilation, and they've said that their goal is to have it be fast enough for it to be the actual default, so you no longer have to do just-in-time. And there are, however, a few limitations imposed on you by the AoT process. So not everything supported by just-in-time is available when you're doing AoT, but I know the doc team is working on a full list of the differences. My view is that in practice, these differences are not a major concern. It comes down to things like you can't be as dynamic when you're defining your providers in your ng modules and stuff like that. There are a few, like you have to be a little bit more static in certain ways, and you can't leverage the compiler at runtime since you're not sending it down. But I find that it's not really in practice, it's not a big concern. So, yep. So the next topic I want to talk about is bundling, because that's kind of the next step. You've compiled your application now, and you want to bundle up your application in the most efficient way. And typically, an Angular app it consists of many files, or modules, if you will. So if you try to serve your app from individual files, it would just be way too many requests. It will slow down your application substantially, because you might be making hundreds of requests. Each file may not be big, but just because you're making so many requests, it's just unmanageable. So this is where bundling comes into play. You take all those individual files and create one or many bundles. Like, it's not always practical to serve your application as a single bundle, because by having one enormous file, you introduce a different problem, right? So in some cases, it's better to spread your application across multiple bundles, and that, you can leverage lazy loading via the Angular router. And so we'll talk a little bit about how we can do that. But bundling is not really just about concatenating files and making fewer requests. That's probably the least interesting part of it. It's more about tailoring your Angular dependencies to the specific needs of your application. Right? If you've done AngularJS or Angular 1, we pretty much had a one-size-fits-all. We all had the same script tag that we included, angular.min.js, and whether we used the entire framework or just a small portion of it, we had the same footprint that we downloaded. So this is where the Angular approach has shifted. Now it's published as individual pieces that you can pick and choose from, right? So if your application doesn't need the forms module, then you don't include it in your bundle, right? There's no need to download unnecessary bytes. So that's a pretty nice way to optimize your application. And on top of that, in the code that you actually do include, there's also a few techniques that we can use to shrink the footprint of even that, right? And we'll talk a little bit about something called tree shaking and dead code removal. And there are a few different options that you can use for bundling. Some really popular ones are Rollup, Webpack, and the Clojure compiler. And I'll talk a little bit about each one. I also, if we have time, I'll do a demo where I have kind of deployed the same app using various techniques, and we can kind of look at some of the pros and cons here. So let's talk a little bit about Rollup. So Rollup is a pretty popular bundler. It's kind of known for what's called tree shaking. Talk a little bit more about that in a bit. The one thing about Rollup, though, is it's limited to a single bundle. You can't spread if you're using Rollup, you can't spread your app across multiple bundles. You basically stuck with one file. So if you're planning on using the router and do lazy loading, you're probably not going to use Rollup. But it does have this nice tree shaking feature, which really is static code analysis. What it does is it assumes that you're using ES 2015 modules, which is a feature of ES6 or ES 2015. And what it does, it walks the trail of import and export statements in your application and figures out if there's any features that are, or modules that are not needed by the application. So if something is exported but never imported, it won't actually be included in the bundle. So if you have this, let's say this is our JS file, we have a greeting service here and a person service. If your application only needs the greeting service and it only imports that from the same file as person service, Rollup is smart enough to go in and figure out, okay, I'm not going to bundle in person service then because it's not actually needed by the application. So it boils down to a kind of a symbol discovery mechanism, right? It looks for imported symbols and then imports them if it's necessary. But the thing is, this whole idea of tree shaking was introduced kind of at the beginning of when Angular 2 became popular, and I think a lot of people misunderstood and have too high hopes of this approach because it's not as intelligent as people might think. Because one of the downsides is that it's limited to the statement level, and a statement in your app can be a class or a standalone function or a variable. So you cannot do a partial inclusion of a class. So let's say you have, if we go back to, if we pretend that person service was much bigger and we had 10 methods in here and we only needed get person, there's no way for Rollup based tree shaking to actually strip off at the method level. It's really still limited at the class level, so you can't really do any fine-grained tuning like that. And another, that could have a compounding effect, because let's say if this module imported other modules that were only called by unused methods, those modules will also be included in your bundle, because it can't know that this is, since it can't strip off those methods, it can't follow that chain all the way in and discard code. It's not that intelligent. And but it is a very smart approach if your code is optimized for it. And that brings me to my next point. Another challenge in Angular is that the patterns in Angular are not completely optimized for tree shaking, because remember, the symbol will be included in the bundle if the symbol is considered to be in use, and what's considered to be in use by Rollup and what's considered to be in use by the programmer, it may not always be the same thing, because if you're registering a bunch of symbols with your ng module, if you picture an ng module, you have all these arrays in the decorator, right? The providers, the declaration, and the entry components, and all these things. Just the fact that something is registered in there means that it's considered in use by Rollup, so it cannot tree shake those things. So that's a consideration if you're creating shared libraries. It may not be the best idea to bundle up everything in a single ng module and push that out, because that leaves the consumer with very little choice. They have to basically include the whole thing. So, okay, I think we've said enough about that. Let's talk about Webpack a little bit. Webpack is another really popular bundler. The biggest advantage of Webpack, in my opinion, by far, is that it can do code splitting, which means you can split off multiple bundles and do lazy loading. Like I said earlier, Rollup doesn't have that capability, but Webpack does. So a lot of times in large applications, Webpack will be the bundler of choice because of that. For that reason, it doesn't really There's a lot of articles about this, but it doesn't really do tree shaking the same way that Rollup does it. It does Uglify. Like it's minification really at the end of the day that it does. It doesn't have a tree shaking mechanism built in. But they just released version 3 and made some nice improvements in there, reduced some of the overhead in their bundles. So yeah, if we compare the two, Rollup and Webpack, really, you get similar results in Angular applications if you're comparing a single bundle. Basically, Rollup will be a little bit smaller, but it's not a lot. It's a relatively small difference usually. But both of them are considered very safe choices in terms of, like, you generally don't have any surprises. If you use Webpack or Rollup, your bundle, after you bundle your application, it typically will work. It doesn't do any crazy stuff in terms of optimizing, so it's generally considered a very safe choice. And like I said, some of the differences are you got the lazy loading and the tree shaking. Then so I want to talk a little about the Clojure compiler, which is a whole another category of bundling and optimization than when you compare it to Rollup and Webpack. The Angular team is working now on adding, kind of wide support for the Clojure compiler in Angular, and they've done a great job. It's relatively compatible right now. I've done some experimentation, and it looks very good. The thing about it is, so the Clojure compiler comes in three different modes. It has 3 different optimization modes. It has a white space only, a simple optimizations, and an advanced optimizations. When I talk about the Clojure compiler, I'm always referring to the advanced optimizations because the other alternatives are not really interesting. They're no better than any of the alternatives, and they're really not worth your time. But if you're going to advanced optimizations, you'll see that it does a much deeper analysis of your code. The difference between the Clojure compiler and these other bundlers is that the Clojure compiler will actually try to understand what your code is doing and act accordingly when it's optimizing. Whereas Rollup and Webpack, they have their ways of optimizing, but they don't go as deep as the Clojure compiler by far, because the Clojure compiler will actually rewrite your code and remove a bunch of code in the process. The downside is because, why, if it's so great, why have you never really worked with it, you might ask, because most people haven't, right? And so it makes a lot of assumptions about your code. And one optimization that it does that's really effective is that it mangles properties. And that means shortening the property names. Like most safe minifiers will not do that. They will, not touch property names. So let's say if you have a customer object with a customer name, the Clojure compiler will go ahead and maybe rename that to a single character name. But for that to work, obviously you have to catch every reference of that property, right? Otherwise, you'll have a runtime problem because if you have parts of your code referring to it as first name and other parts referring to it as A or some other arbitrary single character name, things are not going to go well. And you might have that problem if you're dealing with in frameworks where you have a distinction between HTML and JavaScript. You might have that problem because Clojure compiler works on the JavaScript. It doesn't actually go and look at the HTML. And when you have template bindings, like your first name property might be bound to the template, and if it's renamed in the JavaScript but not in the HTML, you have a problem at runtime, right? Because first name is unknown at that point. So, but this is where the AoT process actually helps, because remember how I said that the AoT compiler converts your template to JavaScript. That means that you can feed the whole picture to the Clojure compiler, right? You can have what used to be HTML is now JavaScript, right? So it sees the whole picture and it can optimize accordingly. And even though it can be tricky in some cases, it's getting, they're very close now to a point where it's not that hard to do it, but you'll still have to make a few adjustments here and there. So I kind of still consider it an expert tool, but I think it will, in time become more mainstream. And And I feel like it's definitely worth it, because my experiments show that you shrink your bundle by, on average, like 30 to 40% if you feed it through the Closure compiler. So I'm just going to take a simple example to kind of show you the process. So let's say take this simple function here, or application, or whatever. You have a simple function here. It returns a message in a property, and then you call that method and you alert the message. So you expect to see a pop-up that says just hello there. So if you run this through like conventional Uglify, you get some improvement, right? But the improvement is mainly from shrinking or reducing the length of names. Like the function is now E, the variable is R, and it's not. You basically, but most of the improvement is from just shortening the names, right? The general structure of the program is the same, but if you run the same app through the Closure compiler, this is what you get. Because the Closure compiler can go through this application and see that in all cases, that's what this will be, right? It will be hello there, a hard-coded string. That's the only outcome that this program can have, right? So this is kind of a, I mean, obviously, it can't always be this effective, but this is just an example that shows you the types of optimizations that it looks for, right? It's not limited to just shortening the names. So it can be pretty impressive. Okay, so what I've done here, I've created a couple of different builds of the same application. So this one is kind of the worst case scenario, where I haven't done any bundling, and I'm serving the application off of individual files, and I'm not even doing ahead of time compilation. And to simulate a slow connection, I'm throttling this at good 3G. And so let's see what happens when we refresh. See, there's a significant delay, right, in getting the app, right? It's very bad performance. But if you look down here, you can see that we basically served 168 requests, right, and 167 kilobytes, with not that much, but since we made so many different requests, this app is very slow. So if we took a look at, let's remove one of those problems. Let's get rid of all the requests. Let's still it won't be doing ahead of time compilation, but it will at least bundle up and do one request. You see here, still not perfect, but much better, right? And so then, if we want to do the same thing, go all in and use the same app, compile with the Closure compiler and AoT. Much better. It's like the performance is pretty good, even on a very, very slow connection, because the bundle is pretty small and the JavaScript very optimized, and it's using AoT. So there's many configurations here that you can play with. You can use Webpack and create lazy loaded bundles for each nav point here if you wanted to. You could really distribute the load across many different routes, and that's another way, right? You don't have to, it's not necessarily just about serving one single bundle that's as small as possible. It's more about how much JavaScript you load at the time, right? Like how much, if you have just a very lightweight request for each time you hit the nav here, that's also a great way of optimizing your application.